When we look at function notation, it's important to recognize that the function notation, what the function notation represents. So there are two parts to the function notation. So there is the red part that I've outlined here. That is the output or the y. But there's also an inside part, which is the input or the x. And it fits into our function flowchart over here. So we have our input x. It goes into the function, which the function takes the input and divides it by 1 plus the input, and it gives our output y. So that is our function. The function notation is going to represent, there's two parts, and it's important to recognize there's an inside part that gets inputted into the x in the function. So for part A, we have f of 2 plus f of 1/2. So the first thing that we need to do is make sure that we recognize the function part of this. And our function is going to be that portion there. It's going to be the input divided by 1 plus the input. For the next portion here, if we move over to the blue part here, there is f of 1/2. Well, we first have to recognize that we're dealing with a function f, which is the input, divided by 1 plus the input. And then we're going to input 1/2. So just to color code this here, this represents the second part. This portion here represents the first part of that expression. Now what's important is that we recognize the inside part gets inputted into the function. So we're going to take the input 2 and divide it by 1 plus the input 2. And for that portion there, we're going to end up with 2 in the numerator divided by 3 in the denominator. The second portion of this, we're going to do the same thing. We're going to input the 1/2 into the input of our function. So we take the input 1/2 divided by 1 plus the input of 1/2. So we've done the second part of that function. So once we've done that, we can evaluate this. This is going to be 1/2 divided by 1 plus 1/2 is 3/2. Over here, I'm just going to calculate that 1/2 divided by, so we're going to times by the reciprocal. Those cancel out. And so we end up with 2/3 plus 1/3, and that gives us a value of 1. Okay, so then we can do the same thing for part 2. Part 2, we want to recognize again that we are starting with the same function f. So the function f, and plus the function f. So I'm just going to do it over here. Oops. It should be equal to 1 here. And I'm going to do it just over to the right-hand side here. So again, we're going to start with the function f, which is the input, and 1 plus the input, plus the input, so f of 1/3. We're just going to look at the outside of it, 1 plus the input. Once we've established the function, we just work out make sure we identify the input of the function is going to be 3. So I'm going to put 3 into that function. I'm going to simplify that. That becomes 3/4. In the second part of that, I'm going to input 1/3. So I end up with 1/3 over 1 plus 1/3. And that is 1/3 over 4/3. Okay, so again, just color coding this. I have the first part of the expression is here, the f, which is shown in red. It's the x over 1 plus x. The input is 3, so I replace the 3 in that expression. The second part of that is going to be this portion here, which is over here. So that function again is f. So notice that the same red function, the x over 1 plus x, and we replace the x's with 1/3 and we get this new expression. So this becomes 4/3, and I'm just over here, I'm going to just do 1/3 divided by, so I'm going to multiply by the reciprocal, and I end up with 1/4. So this becomes 4/3 plus 1/4, and that gives us a value of 1. Okay, so again, the important part is that when we apply function notation, we recognize that there's two parts. There's the f part and the x part, and they are actually on opposite sides of that function flowchart. Okay, so the f, we need to identify the f, and then in that f, we're going to replace whatever's in the brackets. Okay, so in this case here, for example, there is a 2 here, so we replace the 2 in the brackets for those ones. Okay, so there's a 2 in there, so we put that 2 into the brackets. Now, lastly, you may have noticed that both of these gave us an answer of 1. So if we have f of 2 plus f of 1/2 equals 1, f of 3 plus f of 1/3 equals 1, we can maybe guess that f of 4 plus f of 1/4 equals 1, and then we want a generalization for any n value. So that's what we'll do next.